Let's learn about covalent bonds and ionic bonds. The difference between covalent bonds and ionic bonds are covalent bonds are those bonds when atoms they share electrons with each other. So electrons are shared. And in ionic bonds, electrons are transferred from one atom to another atom. So take for example the case of hydrogen. Hydrogen has only one electron, so if I draw that out there, and if hydrogen needs to bond with another hydrogen, I'll draw the other electron out there. Eventually these two electrons, they're going to combine with each other, so they're going to come close to each other, and there you have the hydrogen molecule, and that's the bond between them. Now this bond, it's, as you can see, it's shared between the hydrogens, and therefore that bond is a covalent bond. Okay, now let's say you have sodium which has one valence electron, and then you have chlorine which actually has 7 valence electrons. I'll just draw the electrons out here around chlorine, so that's 7 valence electrons. Now what's going to happen is if sodium and chlorine are going to bond, then the sodium is actually going to transfer its electron over to the chlorine. And when that happens, sodium is devoid of any valence electrons. Therefore, sodium has a positive charge. And then chlorine gets one additional valence electron. And therefore, chlorine ends up with a negative charge. Okay. Now, as a result of this, as you can see, the electron was transferred from sodium to chlorine. And because that electron was transferred, what you end up having is two ions, a positively charged ion and a negatively charged ion out here. So that's another ion. And these ions, they're going to attract each other because one is positive, one's negative. So therefore, the bond, the force of attraction between these ions makes it an ionic bond. Even though covalent bonds that are formed, they share electrons with each other, they can sometimes form charged bonds just like this, okay? And when they do form charged bonds, they're actually called dipoles, okay? So let's take a look at an example of a covalent bond where you can have a charged situation. So let's say you have hydrogen with one electron, again, this time with chlorine with its 7 electrons. And now what they're going to do is they're going to share electrons with each other. Sorry, that got erased. They're going to share electrons to form that covalent bond. And what you have is this kind of a bond. And notice carefully, we don't care about those electrons. Those are the valence electrons around chlorine. We only care about that. That is the bond. But now, in this kind of a situation, even though, I'm going to just highlight that bond, even though the bond is between H and Cl is covalent in character, in this case the chlorine is going to pull the bond more towards itself. That's because the chlorine is different from the hydrogen, and both these atoms have different tendencies to attract electrons in the bond towards themselves. Okay, now this tendency is called electronegativity. Okay, so we can define electronegativity as the tendency of an atom to attract electrons towards itself in a covalent bond. So now once you have this kind of a bond and the electrons are being attracted towards one of the atoms, you'll end up with, so if I redraw the HCl, just the bond, this bond will actually end up leaning more towards the chlorine depicted by the arrow, and you will end up having a partial negative charge. This little sign out here is called a delta. In chemistry, you call it a delta negative. Okay, so delta is the symbol. The negative charge is depicted by negative. And then consequently, because hydrogen, these electrons are pulled away from the hydrogen, therefore the hydrogen will have a delta positive. Okay, So as you can see, this bond is now a polar bond. Okay, so we call this a polar covalent bond. All right. If you look at the previous case where you had hydrogen connecting only with hydrogen, and one thing to pay attention to is this bond is actually made up of 2 electrons. Anytime a bond forms, you're looking at 2 electrons. Because there's no appreciable difference in electronegativity between the hydrogens, therefore these two hydrogens will not attract the electrons towards each other any more than the opposite hydrogen. Therefore, this one is going to be a non-polar covalent bond. All right. The question arises, how would you know if the electronegativity difference between the two atoms is big enough to make it a polar covalent bond or is not big enough to make it a non-polar covalent bond? And for that, let's show you 3 different rules. So if the electronegativity difference is anywhere between 0 and 0.4, then the bond is largely non-polar covalent. If the difference is between 0.5 and 2.1, now the bond becomes polar covalent. And anytime the difference is greater than 2.1, now the bond is ionic. So one thing to notice out here, when the difference is really between 0 and 2.1, the electrons are still being shared between the atoms. Okay, so I'm just going to draw just 2 circles out here to show you. So you have the 2 electrons between them. So I'm just going to shade these circles. Okay, let's shade this one with a different color. All right. So if you have this atom and this atom, the electrons are out here. If the electronegativity difference between this one and this one is anywhere from 0 to 2.1, then these electrons are shared between these 2 atoms. Now they may be shared equally. If they're shared equally, then you have a non-polar covalent bond. If they're shared unequally, then you have a polar covalent bond. Okay. Now, anytime the electronegativity difference goes greater than 2.1, now these electrons are going to get transferred to either this atom or this atom, depending upon which one is more electronegative. So let's assume the pink one is more electronegative, therefore these 2 will get transferred to this atom, and that will result in a positive charged ion out here and a negatively charged ion out here. And then the bond changes from a polar covalent to an ionic bond. Okay, let's take a look at a few examples. So let's say you have the bond, a molecule HF, and you're trying to figure out if HF is going to be apolar, if the bond between H and F is going to be polar or non-polar. So let's go ahead and you'll have to look it up there is an electronegativity table or an electronegativity chart where you'll find the values. Usually most textbooks have those values. So the values for hydrogen is 2.2 and the value for fluorine is 4.0. Okay, the difference between these two values is actually, so I'm just going to depict that as delta En, and that is equal to 1.8. That difference falls under this category, and therefore this bond is going to be a polar covalent bond. All right, so let's take a look at the next example, which is oxygen. So oxygen is the same element. So you have a bond between the 2 oxygens. It turns out there are actually 2 bonds, but it doesn't matter because the electronegativity difference between the oxygen should be the same because it's the same element. So therefore, we're going to do delta En is equal to 0. Therefore, this is going to be a non-polar bond. And finally, let's take a look at potassium fluoride, Kf. The electronegativity of K is 0.82 and the electronegativity of fluorine is 4.0. When you subtract the 2, let's go ahead and do it. That is equal to 3.18. Clearly, 3.18 falls under this category. Therefore, this bond is ionic. I hope that made sense. Thank you for watching.